Hey everyone, in this session, let's understand how can we perform hyperparameter tuning with the help of GridSearchCV. In our previous session, we have discussed about support vector classifier. In this session, we will be using support vector classifier as an example and we will understand what is the importance of hyperparameter tuning and how can we perform hyperparameter tuning tasks with the help of GridSearchCV. Remember, hyperparameter tuning is a critical step to optimize the model performance. Let's understand it with an example. Here we are creating three different models. Model 1 is a default support vector classifier. Model 2, while creating support vector classifier, we are passing few parameters. These are called hyperparameters. Kernel, gamma and C are the hyperparameters for support vector classifier. Now, the value of hyperparameters can change. And if we change the values of these hyperparameters, our model performs differently. If you see for a specific machine learning classification problem, we were using model 1, model 2 and model 3 and these are the corresponding accuracies of the models. When we are using default hyperparameter values, the model accuracy were 0.96. That means 96% of the time our model were predicting the class accurately. When we are using the same type of model called support vector classifier, but this time we are creating it with some specific hyperparameter values. For support vector classifier, we can specify the kernel, gamma and C or the regularization value. By the way, if you are not aware about support vector classifier, I have a video in the same playlist. You can go through it to understand what is the meaning of kernel, gamma and C in support vector classifier. When we were using model 2 for the same problem statement, accuracy went up. Now 97% of the time our model were predicting the class correctly. Similarly, instead of linear kernel, when we were using polynomial kernel and different gamma and regularization value, the model 3 performed the best among these three. Hence, you can clearly understand from this example that hyperparameter tuning can give us a better model for our problem statement. So, hyperparameter tuning is a very critical step for each and every machine learning engineers and data scientists. Now, how can we perform hyperparameter tuning? One option, you can manually create different models and train them, evaluate the score, note it down and choose the hyperparameter values based on the best score. However, to avoid this manual process of creating multiple models and evaluate the score for each and every model, sklearn library provides us an easy way to do the same. We can perform exactly same thing with the help of GridSearchCV. It gives us a systematic way to find the best combination of hyperparameters from a predefined hyperparameter grid. Let's understand it in details. If you see this example where we are using three different types of kernels, linear, polynomial and RBF, and three different values of gamma, 0.1, 1 and 0.5. Now these green circles are the grids. Each and every grid has a specific kernel and gamma value, which is unique. For example, if we choose this grid, the kernel value here is linear and the gamma value is 1. Similarly, all these grids will have a specific kernel and gamma value. For example, this will have polynomial kernel and gamma value as 0.5. What GridSearchCV does, for each and every grid, it evaluates the model accuracy and then it identifies the best parameter values which gives us the best result in terms of accuracy of the model. It exhaustively evaluates the model score for all combinations of hyperparameters. In this case, it is kernel and gamma, and finds out the best combination for superior model performance. Our goal is to identify the hyperparameter values where our model performs the best. Hope you have realized what is the purpose of using hyperparameter tuning and how GridSearchCV can help us to perform the hyperparameter tuning. But everything comes with a cost. Let's understand what are the disadvantages or limitations of GridSearchCV. As GridSearchCV is evaluating all the possible combinations of hyperparameter values to evaluate the best one, it is computationally expensive. GridSearchCV only evaluates the specified hyperparameter combinations in the grid. Hence, it may miss the optimal point. What does it mean? In case of GridSearchCV, we as a machine learning engineers will provide a number of possible values for each and every hyperparameters. And GridSearchCV will only evaluate our model based on the values we have provided to GridSearchCV. Now, based on our experience, if we provide some hyperparameter values which are not good enough for our model, it will miss the optimal point. Then that is one more limitations of GridSearchCV. Basically, GridSearchCV relies on the experience of the machine learning engineer or data scientist. So we as an engineer have to provide the possible parameter values wisely. Let's understand how can we implement GridSearchCV with the help of sklearn library. In order to use GridSearchCV, we have to import it first. From sklearn.model selection, we can import GridSearchCV. GridSearchCV takes multiple parameters. Estimator is the parameter which takes the base model. In our case, we are using support vector classifier. It takes the param grid, whatever we have seen in our previous slide. In this case, we can pass a dictionary as param grid. If you see here, I have provided 3 different values of kernel, 3 different values of gamma, and 3 different values for regularization. Now what GridSearchCV will perform? It will take each and every combinations of kernel, gamma and C values and evaluate the support vector classifier for our machine learning problem and finds out the best parameter combination. Hence, we are creating base model, we are creating params, which is nothing but a dictionary, and we are passing these values while creating the GridSearchCV. Along with estimator and param grid, we are also providing some more parameters. Scoring is a parameter by which we can specify how GridSearchCV will identify the best model. What will be the criteria for identifying the best model? Here we are telling accuracy of the model will be the scoring criteria for our model selection. CV is nothing but cross validation. I have a separate video for k-fold cross validation. If you are not aware about cross validation concept, you can go through that video. And based on these values, GridSearchCV will be trained and then it can provide us the best parameter values we have to use for a superior machine learning model. Now let's jump to the Jupyter notebook. We will see some code so that we can clearly understand how easily we can implement GridSearchCV with the help of sklearn library. In this notebook, let's understand how can we perform hyperparameter tuning with the help of GridSearchCV of sklearn library. In order to use GridSearchCV, we have to import it first. GridSearchCV has been defined within model underscore selection family of sklearn. So we are taking GridSearchCV and train test split method from sklearn.model selection. Here we know what is the use of train test split. If you are not aware, you can go through my previous videos. In each and every video, I have discussed about trend test split method. Hence, we will not be explaining it here now. We are also importing pandas in order to prepare the data. In our example, we will be using sample dataset present in sklearn called load_digits. This is a dataset which will have few grayscale images, and from those images we will be predicting the corresponding digit. Images will be of a specific digit from 0 to 9. We are using support vector classifier to solve this problem statement. Let's load the dataset and then create the feature data and the target data. Feature data is nothing but the independent columns of our dataset. If you see here, we have 64 pixels for each and every image, and each pixel has a specific value because our input will be image, and this is a image classification problem we are going to solve with the help of support vector classifier. So based on these 64 pixel values, we will be predicting the corresponding digit. That is our target. Let's see what is there in target data. This is the dependent column we will have, which is specifying the corresponding digit of that image. With the help of trend test split method, we are splitting the whole dataset into training data and test data. Based on test size, 70% of the dataset will be splitted to train the model, and rest of 30% of the data will be reserved for testing the model. Note, trend test split will have feature data and target data, and it will return xtrain, xtest, ytrain, ytest. Xtrain will have the independent columns of training data. Xtest will have the independent columns of test data. Similarly, ytrain will be the dependent column of training data, and ytest will be the dependent column of test data. Now, in order to perform hyperparameter tuning manually, we have to create a number of models like this. If you see here, the model underscore 1, we are creating with the help of default hyperparameter values. Model 2, on the other hand, has a specific kernel called linear kernel function and gamma as 0.1, regularization as 10. Model 3, we are changing the kernel value, gamma value and regularization value. In this way, there are a number of different combinations possible, and we have to tune our machine learning model such a way that for a specific hyperparameter combination, our model will perform the best. What we are performing here, we are creating the model, we are training the model with the help of training data. Model.fit is the method which takes training data and train the model. Model.score is the method by which we can pass the test data and evaluate the accuracy of the model. Let's run the first model and check the accuracy. If you see here, the accuracy is 99%, which is very high. Let's check with different kernel. With this value, it is 97%. With a different kernel gamma and regularization value, it is 99.4%. This is also 99.4%. So, with the help of this activity, we have clearly understood that why hyperparameter tuning is important for a machine learning model. It enhances the performance of the machine learning model. Our goal is to identify the optimal hyperparameter values, and the process for the same is known as hyperparameter tuning. Now, either we can do like this, manually we can create each and every model and evaluate the score, finally find out the best score and the corresponding hyperparameter values. And this could be hectic in some cases. Hence, sklearn library has given us the feature of using GridSearchCV. In case of GridSearchCV, we will provide a dictionary of parameters where we can specify the hyperparameter name and all the possible values in a list. And we can pass these params within parameter underscore grid so that GridSearchCV will take the base model and then evaluate the accuracy of the model with the help of all different combinations of hyperparameter values we have provided. We are also providing cross-validation. In this case, we are passing cross-validation value as 5. So it will fold the data set into 5 and evaluate each model with 5 different training and test data combination. We have a separate video for cross-validation. You can go through it for details. Scoring is a parameter by which we are providing the criteria of identifying the best model among all possible hyperparameter combinations. Grid search model dot best underscore params will provide us the best parameter combinations from this given parameter list. Let's run this to understand the result. It takes some time because it is evaluating each and every model with all the different combinations of hyperparameters. Hence, it is computationally costly. And after evaluating all the combinations, for example, RBF 1, 1, RBF 0.1, 1, RBF 0.2, 1. In this way, it will take all the different combinations and has identified that when the regularization value is 1, gamma value is 1, and kernel value as poly or polynomial, for this specific combination, our support vector classifier performs the best. Let's run this to understand the best score. Grid search model dot best score will give us the best score for this hyperparameter value combination. If you see here, the best score is 984 or 98.4%. Hope you have realized how instead of creating different models with different hyperparameter values manually, we can use GridSearchCV, which takes all the combinations of hyperparameter values and evaluate the best combination and the best score of our machine learning model for a specific machine learning problem statement. Let's summarize the session now. In this session, we realized why hyperparameter tuning is important and how can we perform the same with manual effort. And then we realized how sklearn library is providing us ease to use GridSearchCV to perform the same thing what we were doing it manually. We know what is the meaning of grid. These green circles are different grids which will have different hyperparameter value combinations. Remember, as GridSearchCV exhaustively evaluates model accuracy for each and every grid, it is computationally expensive. And as it relies on the experience of machine learning engineers or data scientists to provide all possible important hyperparameter values, it may miss the optimal point. So, as an engineer, our duty is to provide all possible values such a way that GridSearchCV eventually identifies the optimal hyperparameter value combination. With the help of code in Jupyter Notebook, we realized how can we use GridSearchCV with the help of sklearn library. Hope you have enjoyed this quick session. Thanks a lot for watching this video.